I'm going to record this for fun. Hello. I am going to make a gaming engine from scrap for fun, just to try and see if I can do it and how long it takes. Here we go. I got a new folder. I got a folder called Game Engine. I'm opening it up in Visual Studio Code because that sounds fun. I'm going to make a new file called an index.html. Hooray! Just do an exclamation point and tab out from there, and let's go ahead and call this game. Yeah. Now, at that point, what we want to do here is we're going to want to pull in a file. We're going to call this main, I think. So let's pull in a script, and let's pull in a source, and let's call it main.js. But let's put it in a folder called source. That's usually a good idea. Let's also give this a type of module. And that means it's going to pull in as module code. That means it's going to be in strict mode. That means that it's going to have its own scope. It's going to have a lot of good things. It's a good idea. And let's throw a canvas into our document. There we go. Hooray. Excellent. Let's make a new folder. Let's call it source. And then inside of there, let's make a new file, and let's call that main.js. Now, at this point, with this main.js, what we're going to do is we're going to make a new class, and we're going to call it game. And then when the document has loaded, let's go and call game, make a new game. Let's say that when the DOM content is loaded, then we want to make a new game. There we go. Excellent. So once the document is ready to load, it will make a new game. And then what can we do? Well, let's make a constructor, because that seems like a good idea for our class. And inside of here, let's get the screen for right now. Let's get a level. And let's say our level is a new level. Why this? Well, because this is going to allow us to, in the future, this game right here is going to be the core of our whole engine. It's going to run everything, but it doesn't need to know anything about what kind of game you're going to make. This is going to be a thing that makes a game, and then we can make a level, and the level can be something that defines what the game is from any game to game. So at that point, let's say that this.previousTime equals a new date. Then let's make a function called run and run it. So let's make a function called run and run it. Let's also make a new file, and we'll call it level.js. And inside of here, we'll export a class of level. There we go. We've now got that. Let's go back to our main. Let's go back to our level, and let's just delete this, type this. It's going to try to import our level now in VS Code, which is fantastic. It's going to do it wrong, though. For some reason, it always does. I don't know how to do it right, but we need to call it level.js, not just level when using JavaScript modules. Okay, so now we can run. What do we now want to do? Well, we need to create what's called delta time. Let's let a new time equal a new date, so a new timestamp. Let's create a standard setting that all of our objects can import from anywhere inside of our module code. I'm going to skip a couple steps here in explanation and just say that we're going to make a new file right here, and we're going to call it settings.js, and we're going to import something that I don't necessarily want to write right now, but it's called settings as a class. Now, here's the way this class works. It's basically an object that has only static properties. It has only static properties, so this is essentially a static class. And what that means is that this class never gets instantiated as a new instance of settings. It only ever gets used as the class of settings with its static properties. So that means that because it never gets instantiated, no module ever has their own settings. Every module has access to the group settings. Everybody has access to the same settings. And this basically just has an add and a get and a remove. And it's just basically a way of adding data that any of your modules have access to. And so now I am going to go ahead and add a new settings. Let's make a settings, and it's going to import it. And now that we've told it to import as JavaScript, it imports correctly this time. Let's import the settings class, and let's set a property called DT. And this is going to be our delta time. We're going to use our new time minus this dot previous time. And then we're going to divide that by 1,000, which is because we're in milliseconds, and we want to get that down to something more reasonable. And then we're going to set the previous time to equal the new time. Oops. There we go. And at that point, we're going to take this dot level, and we're going to run it. And then once this has run, we're going to request an animation frame, and we're going to run a tick. And it turns out that right now we've got this all inside of a run function right here, and we've just called a run function on our level as well. So let's just go over here and let's make a run function right here, because we're going to want that. And what I've said is I want to run a tick function, but I've already in a run function, and you might be thinking to yourself, well, that seems ridiculous. Well, this game needs to set up something arbitrary. And then this run needs to run arbitrarily, and it needs to run continuously. But I need the game to stop doing anything and just let this do whatever it needs to do forever. So at that point, what I'm going to do is I'm actually going to say that there's a new constant called tick right here. And that actually has all of this code. And that as soon as we run, we call this tick function. And so that means that this tick is now something that gets all of this. Do I need to do that? You know what? I'm doing that because that's the way I was doing it, but I don't think I need to do that at all. Actually, let's take that back. Let's say that this is just this dot run. And let's make run a arrow function so that it has access to the this while being called right here. That's a good idea. So if you ever need to use if you're ever using classes and you need to call an asynchronous function, like you need to pass one of the methods of that class into an asynchronous function, what you're going to want to do is make that asynchronous function an arrow function, because then it's this inside of there will be determined as the class as opposed to the window. If you don't do that, if it was just a regular function right here, if it was just a regular method, this.run, when it tried to use this inside of it, would not access the game's this, it would access the window this, which would not be optimal. That's not what you want to do. So at that point, we've got a... This is our game engine. This is it. This is the start of a game engine. We now have something that is running through and looping over time. We have a stored value of a delta time that we can use to slow down or speed up or set the pace of any of our timings in our game. And this is the core of a game engine, because you can make a game in regular HTML. But when you've got millions of things going on, you don't want them all to have their own event lookups or their own event listeners. You want some core listeners that can provide some core functionality, and then you want those core listeners to loop through and handle millions of objects instead of millions of objects all trying to handle themselves. And that's what this allows us to do, is it allows one game loop. Just right here, this one game loop right here is going to run your entire game. And at that point, we're running this as a module for a canvas. And then we've got the ability to run a level right here. So then what can we do? Well, at this point, we can say console.log running. And this will now run something a lot. So let's go ahead and try to run this. Now, VS Code has an extension called Live Server that you can use. If you get the Live Server extension, then what you should see is down in the lower right, you'll see a little Go Live button. And if you switch back to your index.html and you click this little Go Live button, then what it should do is pop you open a page. And at that point, if we look at our console, we should see that there are a number of instances running, or that this thing is getting run over and over and over again, and essentially our game engine is running. We have a loop that's running over and over again, and it is calling our level, and our level is console logging running over and over and over and over again. So that is working, so that is terrific. Hooray! That's the goal. That's what we were trying to do. So at this point, what else can we do? Well, we need to do some other things, perhaps. So let's go ahead and see if we can just draw a circle wherever our character is. Let's say that when our level is initialized, let's give it a constructor. Oh, let's stop this. We just quit that. Then we can set up some things for the game that we're running. And sometimes it's even useful to set up an asynchronous setup function, because that way you can call any data that you need to call or anything like that. You can always just call this .setup, and that way, even though the constructor is usually not asynchronous, the setup process can be asynchronous, and it can call whatever it needs to do and do any awaits or anything like that it needs to do. At that point, we want to get the current size of our window, or let's say let's call this set screen size, and let's make a function that essentially goes out and grabs the canvas and sets it to full size for the screen. So let's say that the let w equals window dot inner width, and let's say that there is an h that equals the inner height of the window. And let's go out and get our canvas. So document dot query selector for our one canvas element that we have. And let's set its width to equal w. Actually, let's just go ahead and say let canvas. Actually, let's do this. Let's grab this canvas right here. Here, let's say that this is canvas equals this. Let's grab our canvas. And let's set that up in our setup. Let's actually say that this .canvas equals our document canvas, because I think we're going to want that in the future anyways. And let's just say that our this.canvas .width equals w, and then our this.canvas .height equals h, and we've now set our width and height to that. Let's also go ahead and give ourselves a little bit of CSS. Let's say that our canvas has a position of fixed. Let's say it has a top of 0, a left of 0. Let's say it has a width of 100%, a height of 100%, and that should put it at the top of our screen, ignoring any margins that a page usually has, and it'll allow us to just cover the whole screen. So then at that point, we are now setting its width and height. We've set its width and height 100% here in the style, but it turns out that this is, imagine this canvas is an image that you might put into your web page. if you change the width and height of the CSS, it's going to stretch that image. And that's what this would do. Setting our width and height here is as if we had gone into Photoshop and resized that image, or set the size of that image. This is setting the actual size of the image, and this is just stretching that image. So we're going to stretch the image, yes, but then we're going to immediately do the exact same thing and set the canvas width and height of our the pixel count of our width and height of our image, as opposed to the stretched size of our image. So these two things work in concert together. And so now we have this. So we're going to get our canvas. We're going to this dot set screen size. And now we have our canvas should be full size. If we go live again, let's check this. Let's just look at this thing now. We should have a full-size canvas at 1920 by 973 or whatever it is. Now, I just resized my screen because I brought up the dev tools, and that's probably something to think about. But yeah, that looks like it's worked. Let's go ahead and move this over to here. And then let's move this over to here. So that I have just both of these things up at the same time. Let me just move this over just a little bit. Now, since this is actually a live server, whoops. Whoops. Come on. There we go. Okay, since this is a live server, then this is going to update every time I change something. Every time I save, this should reload. I don't need to keep going live and ungoing live. This can just be open. It doesn't need to refresh. It will automatically refresh. Okay. So I now have my screen size, my canvas size is full size. Let me go back to inside of my level, and while this is running, let me get the current mouse position. Now, in order to get the current mouse position, I can't the way that browsers work is they work off of events, and the way that games work is they work off of time, and they're not the same concept. You don't know where the mouse is at any one time except when the mouse moves in a browser. So when the mouse moves, then the browser knows that there was a mouse move event, and then it triggers a mouse move event, and anyone can listen to that mouse move event. What that means is that we're at a bit of a disadvantage because we need to know the mouse position at any one time in our game, but the mouse doesn't know where it is at any one time in the browser. So we need to actually build ourselves sort of an engine. So let's make a new file. Let's call it pointer.js. We're going to make this extremely simple. Let's export a class of pointer. And on constructor, let's set up a couple of things. First things first, let's say that window dot add event listener for mouse move. We can add a number of these event listeners if we want to. Let's call a function called mouse move. We'll say this dot mouse move. And then let's make a function called, now since we're calling this as an event, we need to make this as an arrow function so that it knows about the this of the pointer. So let's make a function called mouse move. And let's make sure that it's getting past the event data of the mouse move. And if you've never worked with mouse events before, then you might not know all about this. But essentially, what we need to do is we need to get the page X and page Y. Since we're going full screen here, we need to get the page X and the page Y of our mouse move and then set that. So let's say that we also want to use a getter called position. And our getter of position is going to return a it's going to return an xy coordinate of this dot x and this dot y. Those don't exist yet, so let's make them in our constructor. Let's say this dot x. Actually, we can probably just put those at the pointer right here. We can say x and y right there. So those are set. Now you can see here it's actually bulking at this because it doesn't like the fact that we just tried to pass an object here without any properties. So let's just say x equals this and y equals this. There we go. Okay, so by making this getter right here, what we'll be able to do is we'll be able to say our pointer position. We'll be able to call it without calling it as a function. We'll be able to call it as a value. This allows to set a property that is a function, which is a useful thing to be able to do when you want to do it. Okay, so that's a getter. Let's do a setter. Let's say xy, and let's say that when we set this, we say this dot x equals x, and we say this dot y equals y. So we've now got I lied. I don't want that to be a setter. I just want that to be a function. There we go. At this point now, what I want to do is I want to this dot position. You know what? I lied. I do want that to be a setter. And I just want that to be an object. It's going to get passed into it, which is an xy object. And I will say that this dot position equals an x of e dot page x and a y of e dot page y. Excellent. So we should now have a pointer class that when the mouse moves, it should be able to update this pointer's understood information. However, we come across an interesting problem. The pointer, I think, should be something that's set up once again because our game works in a different way than a browser works. I think we should set this up not as a class that gets instantiated every time it's needed, but instead a static class that gets that sets itself up once and then everybody uses the exact same one. So let's actually set these two things right here to be static variables. And that means that here what we want is these two things to be static, and then we want these two things, and these two things. Now, the reason of these naming, static means that it is a value that only is accessible to the class as a concept, not as an instance. And this little hashtag right here in JavaScript basically means that it's a private variable. So that means no one can say pointer.hashtag_x outside of the pointer. That's only accessible inside it's a private variable. Let's go ahead and therefore set these to be static as well. At that point then, if this is always a kind of a static class, then we don't really want a constructor here. We want this to be like an initialization function because there is never a constructor. This thing never gets constructed. So we'll call an init function instead. So in our level, for the setup for this level, actually we could probably do this in the main.js. That's probably where we would want to do that. We'll call a pointer .init. So when we first set up our game, we'll set up a pointer. Do we have an error? Pointer.init is not a function. That's got to be static, because there we go. All right, so we now have a pointer available to us that always knows the position of the mouse, or at least the last position of the mouse that was available to it. So then at that point, what we can do is we can change our level to console.log pointer .position. Now it's got to be pointer.js. Whenever you import a file for the first time in a level, it's got to, okay, so these are undefined. That does not seem to be working. Let's see here. Oh, this needs to be static as well. There we go. All right, so now, there we go. So we now have the position of the mouse at any one time on our screen. However, you'll notice that when we first saved this, it was coming off as undefined. Let's just go ahead and say in our init that this dot x equals 0 and this dot y also equals 0. So we'll just set those to a simplistic value so that they're at least set to something until they actually get set to something. Excellent. We now have a pointer. We now know the position of our cursor at any one time. We could easily extend this to do even more things, such as we could say on click. We could do on click. You know what? That's probably better to say on mouse down. So we could say on mouse down, and then at that point, this would be basically the exact same function. It's going to have the exact same information inside of it. But now we can do more with that. We can then say that we want to do another one, and that this is all mouse up, and we could say other interesting information, such as actually this probably doesn't do that at all. If anything, we could say that whether the mouse is down or not. So we could say like I don't know. We could do something else that I don't actually want to do right now. You can do more things is the point. So we can get more positional information. We can get all kinds of information from our mouse in our pointer class now that we have it, even though right now the position doesn't matter as much from when I'm moving it. Okay, so at that point in our level, this isn't as useful. So let's get the pointer position and let's do something with it. Let's draw to the canvas. Let's get a context for our canvas. Let's say that this dot context equals a new context, our this dot canvas dot get context 2D, which is going to then allow us to do canvas writing. And once we have the context, we can use that. So we can say this dot context dot draw. Well, we can't. There isn't really. Context is annoying. So there isn't really a way to draw with the context. You have to sort of set up a whole bunch of things. So that's why I usually end up making a whole series of canvas classes that make things a lot simpler. So let's go ahead and let's make a new file, and let's call it canvas.js. And inside of here, there could be, oh goodness, lots and lots of fun options inside of here. But let's go ahead and let's make an arc. Let's make a draw circle. Let's make a, let's export a const called draw circle, and let's make it equal a function. Let's say it gets past a context. Let's say it gets past an x and a y. Let's say it gets past a radius, and then let's say that it then gets past 3 angles, angle 1, angle 2, and angle 3. Then we can do a context dot begin path. We can do a context dot close path after that's done. And we can then do a context dot fill. So we can do a context dot arc, and the arc is going to have basically all of these values placed into it. Actually, we're going to say that this by default equals true. And then we're going to try to draw a circle. So how do we draw a circle? Well, we want to draw a circle. which is going to be imported from our canvas.js. We're going to pass it this .context. There we go. We need an x and y coordinate. That's going to be our pointer position. So we've got our pointer position .x, and we've got our pointer position .y. And at that point, we need a radius. And our radius, in this case, we'll say is 10. So we've got our radius is 10, and then we need a starting angle and an ending angle. So generally speaking, that means you're going to do 0 and math.pi times 2, which is a circle. And we're just going to leave off that last value because I don't think we really need to do it. So let's save. And something is being drawn up there. And now something is being drawn here. And our game engine is running. There we go. We are now off to the races. We have an engine that knows a whole bunch of concepts. It knows about time and how much time has elapsed. That's our delta time. It has settings, proper settings that any module can have access to. It knows pointer positions, so it knows concepts from the browser that are usually event-based as constant values, something that is always available to them. And it has a concept of setting up canvas functions to make certain things, like designing out a circle is usually a painful, annoying process, but just being able to set it once and forget it is great. So let's make another one of these. Let's do a draw rect. Let's export a const called draw rect, a rectangle, and let's set that to something. Our draw rect is actually quite simple, in fact. Do almost the exact same thing as before. We can expect a context. We can then expect an x, a y, a width, and a height. And at that point, instead of arcing, we can say that we want to make a rect. And that rect is going to have an x, a y, a width, and a height. And that will then be able to set a rectangle into our screen. And so if we do that, then we can come back over here, and before we ever draw our circle, we can draw a rect. With our this.context, we can then say that we want it to be 0, 0, and our canvas size. For right now, we'll just say that it is this, and this. So we are now going to draw a rectangle across our screen like this. So far, we haven't actually given any options to our thing for like colors or something like that. Let's make an options available to ourselves, and let's say that there is a fill style, and that the fill style in this case is white, or in the case of our circle, we'll make it red. And then we actually had this extra option right here that I'm actually going to remove from our canvas. I don't think we need that actually for right now. So let's just remove that. We're not even really using that. Let's just say we're not even really using that. Don't even worry about it. Okay. So that means that right here, we're actually going to say that there are some options, and we don't care what the options are. What we care about is that once we're inside of here, we want to take our context and we want to do an object assign. And it's going to take the context and it's going to assign our options to the context. And that means that our normally when you do the canvas, you have to do this whole set of values and have to set them one at a time, and there's no simple way of setting them, but this gives us a simplistic way of setting all those things. Cannot read properties of undefined context. It's not this.context, it's just context. There we go. All right, hey, look at this. Now we have a circle moving around, and our canvas is constantly having white stamped back on top of it, so that it's clearing out wherever the old circles were, which is what we was having before. And now we have our circle moving around with our cursor. So, have we learned how to move a circle on our screen? No, that's not the point. The point is that this is now the start, a very decent start, to a gaming engine. We now have the ability to know about time, know about position, know how to draw, and we have a single source of truth for all of that. And we have a run cycle that happens inside of our level. And this is getting called every single frame in our game. And that's a game engine. That's how games work. From there, it's just what else do you want to do and what other math do you want to do. But I think this is really super important for a person who wants to start making things in JavaScript Canvas. What you should know is that although there was this one thing that we pulled in, everything else we sort of wrote from scratch. And at this point, this is a very good start for any game that you might want to make, because essentially this is going to be the same for every game that you ever want to make. This is the same concept. Once you've written this and written it out and made it big, that can be imported. Once these canvas functions get built out by you, they're easy and can be reused over and over. And then everything is just in this level. This level right here is the unique concept, and this is where the game happens. And that's all you need to make a game. That's all you need to start making a game in JavaScript. At that point, it's all about making something that you need for that game. It's all about building out your pointer class, building out your canvas functions, building out your timing functions, or all of that kind of other stuff. And then building out all your algorithms for whatever you're trying to do. But this gets you to drawing on the screen and drawing in the canvas and looking like every other gaming engine you might see anywhere else. And it doesn't take a huge library to get going. You can get going very, very fast. And this is the way you can do it. There you go. That's all. I don't really have anything else. This was fun. I don't know if I'll even put this anywhere. You know what? I'm putting this on YouTube. Fuck it. This was worth it. Yeah. This was fun. There we go.